In this lesson, we'll understand the implementation of principal component analysis and clustering with the airline data case study. We'll visualize the data and extract the PCAs first. Then, using the eigenvalues and scree plot, we'll decide on the suitable number of PCAs, that is principal components. We'll further analyze data along the variable and individual dimensions. We'll examine the quality of representation of variables and individuals on these principal components. We'll also visualize the variables and individuals on 2D factor map, the dimensions being PCAs extracted, PC1, PC2. We'll also visualize the contributions from variables and individuals on these PCAs. Finally, we'll compute 3 and 4 clusters using k-mean clustering technique. Also, we'll employ survey data containing brand image, price perception, value for money, and features to identify the latent PCA dimensions and correlate with these survey variables. In this video, we'll introduce the airlines case study on principal component analysis and clustering. To begin with the case, you're a consultant to an airline company. It wants you to do a competitiveness and positioning survey. This requires you to examine the company on various parameters, including brand image, price perception, value for money, and features. Based on your experience, you conduct 2 surveys. In the first survey, you randomly select 27 customers and ask about their airline preferences amongst 10 commercial airlines and give them overall points in airline data file. In another survey, you separately choose 27 random customers and request them to give scores to the same airlines on their brand, value for money, and various other features. You also collect historical average prices on common routes, which is available in survey data. Now, to complete this consulting assignment, you need to carry out the following analysis. First, you need to load the airline and survey data, summarize and visualize the data. You need to conduct the PCA analysis and extract the factors from the airline data. Next, you examine the eigenvalues and compute the share of variance explained by each of the PCAs. You need to draw the plot of variances, scree plot, and select the relevant set of factors from the data. Next, examine PCA results with respect to airlines variables. Examine and map each airline with respect to each PCA and visualize the coordinates with a 2D factor map and plot different airlines on these factors in combination of 2. Examine the relative contribution of each airline to different dimensions, that is PCAs. Examine PCA results with respect to individuals also. Examine the mapping of each individual with respect to each PCA or dimension. Visualize the coordinates with the 2D factor map and plot different individuals on these factors in a combination of 2. To conclude the case study, you also need to examine the relative contributions of each individual to different dimensions, cluster the individuals as per their attributes on the graph. Using the survey data, identify the dimensions, for example, price perception, brand image, VFM features extracted from the principal component analysis. And with this, we conclude the case. From this video, we'll start with our airlines data case study on PCA and clustering. As a first step, we'll set the working directory. So we get all the files and everything on relevant place. This is the location where I have all my data and files. So for record, I'll just copy paste this location that I need. So I've set the working directory. So the first step, we'll set the working directory and load the packages. Now, just as a test, if I have done everything correctly, on my files tab, the data files, airline and survey will appear. They are there. That means I've set the working directory correctly. Now we'll load the relevant libraries. Please remember, I have already installed these packages, so I'm just adding it to the current working environment. If you have not installed them, you need to first install them before this library command and adding them to the current working environment. So for ggplot, then gg45, gg45, grid extra. So facto extra library plot and library. So these are some of the libraries we plan to use in the session, in this exercise. So now we have loaded the relevant libraries, set the working directory. So let's start with first part. In this part, we'll load the variables, load the data and visualize, load the airline data and visualize. So for that, let's use a simple route. We'll click on this airline.rds and load it. The data is already read, but for reference, for future reference, you can just keep this file. I need not have this full command because I have already set the working directory. It has a lot of benefits. For example, I only need to give the file name. I don't have to specify the full address. And if I have done it correctly, the data is properly read, I can run this glimpse command airline. So you can see what this data is. It has 27 rows. Each row indicates the data about individual. There's survey points to airlines 1 to 10. So each column is column 1 is airline, which has now the representation may seem to be like row is this, but no, this is sort of column as when you'll print the data. So let me show you. So if I print the data, the columns are airlines and rows are individuals. So let us go back to our glimpse command. So you can see there are 10 airlines, score of individual, 27 individuals are collected. The best way to visualize this, now this needs a small trick. What I'll do is, in order to visualize, first I need to split because there are 10 airlines, I need to split my plot window. Now right now I have a one plot window here. I need to create sort of maybe 2x5 or 5x way. If you've seen this command, if you've worked before on R, this command will split the R split in 2 rows and 5 column kind of setup and give me a nice plotting area. Now I can apply a for loop and you'll see the interesting use of for loop here. 1 in 2 10. So this I in 1 to 10. So what will happen is this I variable will run 1 to 10 times. And what I want to do is I want to each time this code runs, I want to plot a histogram which will contain airline data. Each time ith column will run. So with this command, the indexing that I'm doing, the subscript I am using, every time the ith column starting from 1 to 10, that means airline 1 and so on will be, the histogram will be printed. Now very interesting color scheme I'm using. I'm fixing color with the variable I. So R has each color indexed to a number also. So for example, 1 would be indexed to some color, 2 would be indexed to some color. So every time this loop will run, the histogram will be plotted and color would be indexed to I. I want to make a nice central heading name. So I'm using this space command that will combine two strings. So one string is airline number. And now I'm using a variable I. Again, same dynamic indexing where I'm using I. This I would change every time the loop will run. Airline number is a string which will remain constant, but it will be merged or sort of combined with the variable I, which is more dynamic. Now, the last part is I want to keep the xlab empty. So I don't want to do much. So this is done. Now, so I just want to be sure. So let me run it. So yeah, so you can see all the 10 airlines, airline 1, 2, 3, and then so on, their plots are given to me. And the colors are different because I have indexed the color with this I. So it seems there's some repetition after 6, 7, 8, 9, 10. So after 8, there is some repetition. Seems that 9 and 1 and 10 and 2 are similar. So, but still we get the point. We know what airline numbers they are. So we can visualize the data like this. So this is our data visualization. So to summarize this video, we set the working directory, we added the relevant library packages, read the data, we summarized the data and visualized also. Looked at the histogram plot. From next video onwards, we will formally start with the principal component analysis exercise. From this part, we'll formally start with the computation of PCA. So we'll start compute PCAs. We'll give the variable name as PCA and the command is simple. This com command will compute the PCAs for us. One thing we should remember that you have to scale the data. If you do not scale, you'll get very odd results. So scale the data. So this PCA variable carries our PCA. Let's have a look at this PCA data, what we calculated. So these are PCAs that are there. Their loadings are provided. But on its own, it's very difficult to make sense of this data. So we need to sort of make this data more meaningful for us. So the first thing we'll compute eigenvalues. So let's call it eig.val eigenvalues. For this, the command is simple: get underscore eigen, and you provide your PC objects here. So this will carry your eigenvalues. You can print them, and now it will make more sense. Look at the eigenvalues along the each PCA dimension. The first PCA has this eigenvalue of 3.74 and it carries 37% of your variance. The second carries 17, 15 and so on. So if you want to extract factors at least that can explain 10% of your data, you would have 4. If you want at least 15%, then you'll have 3 factors. So probably 3 to 4 factors would be a good choice here. The Also, one way would be to visualize the data through scree plots. So you can visualize the data with scree plots to examine how variances are stacked up. So what we can do is already we have sort of splitted the plot. So we'll first sort of increase this and clean this plot. So we need to clean the previous plot and then only we can draw the fresh. So what we'll do is we'll plot PCA, or rather that would be slightly odd. So we want scree plot. So we'll have this score eigen. So this would be probably a nicer plot. So you can see nicely the first factor almost 37, then you can see here 17, 15. So it seems 3 to 4 factor choice would be good probably. So we have seen the scree plots now. Now let's start the analysis in a more detail, starting with PCA results relating to variables. Now there are two dimensions, either you can relate them to variables or individuals. So let's start by relating them to variables. We can extract the data var get underscore PCA. So here we'll put the var. Similarly, if you want, you can do it for individual as well. All you need to do is just change the command here a little bit and provide it for in variables. And so here it is for individuals. Now the question is, what is inside these objects? So if you want to know, what you can do is you can just print the object. You can see it carries correlations, coordinates, cost to. Cost to is sort of effective, how effectively the dimensions are plotted. What is the quality of representation of each dimension in the PCA? And same goes for individuals. So let's do it one by one. So one way is to plot the loadings, visualize sort of loadings. Let's do it. Visualize the loadings. So this core plot is very useful. Not the So these are quality of projection, rather quality projections. So we can use this core plot. And here there are two ways to: one on the dimension along the lines of variable, and is dot core. This is useful because this is not correlation. If it is otherwise, it will create from -1 to 1. So we tell it that it's not correlation. You can see if you look at individual dimensions, your dimension 1 has like 7 airlines associated, dimension 2 has airline 8 and 4, dimension 3 is sort of giving more this thing to airline 9, and dimension 4 gives to airline 10. So this way we know which airline is getting captured in which dimension. If you want, you can do the same thing for individuals also. So the quality of projection for individual is slightly more clumsy, but so you can probably, if I zoom it, you can see what do a better dimension wise quality analysis. So let's say you want to see individual dimensions, how they explain. So dimension wise analysis. So what you can do is you can use this fvis cos to plot. It will give you a nice dimension wise plot. So let's say first let's go by variable wise. So suppose if I pick only one axis, because the first principal component which explains the max on. If I keep on increasing it, so let's say 1 to 3, I would be explaining a lot of it, you can see. And if I keep on increasing that, let's say I add 5 dimensions, lot would be explained. You can see the amount of explanation is increasing, only a small bit left. If I do it for 10, everything will be explained. So with 10, everything will be, I can change individual. If I do it, you can see certain level that it's explained, and I can keep on increasing it. So it will be increasing a lot. And finally with 10, you get full explanation. So with 10 dimensions, you get the full explained variables as well as individuals. We also saw if for each 1 to 10 PCS, how quality of explain each of these dimensions, particularly the variables, airlines, or individuals, are explained with adding more and more PCAs in the data. So with this, we close this video. In this video, we'll do some advanced data visualization exercises related to PCA. So let's start with plotting factor maps. Factor maps for variables and individuals. Let's, for variables, it makes more sense to visualize on factor maps. Let's see how. So we can make more sense of these variables with factor map. So we need to provide the PCA variable. We need to also specify the axis. Generally, it is best to choose the first two axes because these are the principal components that explain the data best. So I'm choosing the first two. You can change it later. We'll see how to change them. You need to specify the color of the this thing. So cost2 is the variable because it shows the quality of projection of data, how good data is represented. Then you have to specify the gradients. Generally, in this argument, you can I tend to randomly choose some colors, maybe green at one end of the spectrum, in between a little bit yellow, and by end of it red. So this would give me the color spectrum. If you want a little bit this thing to be dispersed, you can use a REPL argument. So if I find that these are slightly, so it's not that cluttered. If it was cluttered, I would have used the REPL argument, but I need not do that. So you can see how airlines on these dimensions are very well captured. So you can see airline 1 is here, 2 is here, 4 is. Color gives you the quality of representation. So the more color means more better projection. For example, let's say you want to change the dimension. What you can do is you can change the dimension. Let's say I want 2 and 3. You can do that. And you can see how it aligns, but the quality of projection would be lower because in this case, what is happening is we are using the lower PCA. So I can skip that. Now we can also do it for individuals. For example, I'll not do for maybe for these two, I'll do for individuals. What you can do is you can just change this to individual. And in addition to that, you can here you can change to individual. Lastly, so this is good. So let's run this. And you'll see how individuals are grouped and picked here. So you can see individual dimensions here, dimension 1, dimension 2, and different individuals plotted. You can see which individuals are together. This exercise is very useful in clustering your target segment, but this exercise will be done more in a more formal manner with the clustering analysis. So we can stop here now for this exercise. Next, we would like to visualize the contributions along the lines of variables and individuals. How do we do that? So we'd like to visualize contributions for variables and individuals. So let's start with the variables. So what we can do is we can use our contribution PCA. Now choice is for variables for now, and axis we start with different, say let's say start with first axis, and you can see how they are, the contribution is. So for dimension 1, it is like somewhere around contributed to 17%. For dimension 2, it is around 15%, and so on. If you keep on increasing the contribution, maybe 2, it increases. You can see when you have two dimension, sorry, two mistake I made 10. So 2 dimension, so quite a lot of, so for example, are explained after inclusion of 2 and so on. So you can see now if you put it 10 here, then everything will be explained. So this was for variable. So you can identify which is plotted where. Similarly, if you want to know the contributions on individual dimension, all you need to do is change this to individual, and you can see which individual. So you can see with dimension 1, which individuals are captured more. Similarly, if you had 2 dimensions, a lot of it would be captured. And if I had 10 dimension, then quite a lot of dynamics along the individuals is captured with 10 dimensions. So this way you can see the contributions. Finally, as a last result, I would like to do the clustering exercise. As we have discussed already how clustering is done, we'll be doing k-means clustering. And in this, I can go with the 4 clusters. So let's do that with k equal to 4. And you'll get clusters like these. I can zoom it. So you can see how clustering is done. So these individuals in slightly violet color, purple color, they are there. Then these individuals here and this. So you have 4 clusters. These 2 red and green clusters are slightly touching each other. So if you want to make it more perfect segregation, so you can probably give 3 cluster, and then clustering would be more sort of segregated. As you can see here, red, green, blue. So very segregated clusters. And so this kind of analysis would help sort of doing target segmentation a lot. So with this, we did some advanced visualization of PCAs in this video. We also did the clustering exercise. In the next video, we'll try to identify what dimensions these PCAs are. In this exercise, we would like to identify the dimensions with some physical meaning assigned to them. For this, we have also survey data with us. Let's load the survey data. The survey data, let me load the data first and then simplify this name. Let's have a glimpse of the survey data. If you look at the console, the survey data contains some data collected related to historical prices, brand perception scores, value for money, and some feature related scores from the consumers. We would like to associate these dimensions with the hidden latent PCA value. The reason is we do not know what these animals PCA are. We understand that these less number of dimension reduced PCAs can explain data well, but we need to know in order to make some policy related implication, we need to know what these dimensions are, at least have some shape, some thing about this animal. So what we'll do, we'll see with the survey data. Let me combine this survey data. And in order to extract the PCA factors, there's this rotated factors available with us. So these are your PCAs and along with their loadings. What we need to do is we need to combine these PCAs along with the survey data. So this, I'll combine them. Let's me call the new data frame combine, and I need to combine them column wise. So C bind data frame. This will combine my data, survey data along with the factors. Now let's compute the correlation of the factors and let's interpret them. So as you can see here, let's start with the first PC1, and this PC1 is highly related to the price. So we can say PC1, a lot of PC1 comes from price. VFM is generally correlated with price, so we can say that same thing is overspilling here. VFM. PC2 is predominantly, we can say, coming from sort of brand side. So PC2 is coming on loading on brand. PC3 is loading on value for money. Negative suggests that probably it is on the lower the better, for on the lower side of it. PC4 is loading on features. So we can see the initial four dimensions, they are loading heavily, and in fact it has a somewhat VFM correlated with VFM with features and so on. So we can now relate these PC dimensions, PC1 with price, PC2 with brand, PC3 with value for money, and PC4 with features. So we have some idea there. So with this, we have identified the factors in this video. We have identified some more meaningful dimensions such as brand, price, features, and so on. So with this, we conclude the exercise. To summarize this lesson, we started the case study implementation by setting the working directory, loading the relevant packages, and reading the data. Next, we did the exploratory data analysis. As part of this exercise, we explored and visualized the airline's data. Next, we extracted the principal components and computed the eigenvalues of these species. Principal component analysis suggests that the first four PCs capture 37.5%, 17.5%, 15.2%, 10.3% variation in the data respectively. The escape plot and variation analysis suggests selection of 3 or 4 factors to represent the data. Correlation plot suggests that PC1 captures airlines 1 to 7, airline 8, 9, 10 are captured by PC 2, 3, and 4 respectively. PCs we mean principal components. We also analyze the data along the individual dimensions, and with 4 PCs, most of the variation data is explained. We also visualize the variables on factor plots with PC1 and PC2.